Everyone, Miss Train talking here. I think this may be the last video for chapter 5.4. 5.4 is a little bit abstract and a little bit long, okay? So bear with me. I think you're doing a great job. Okay, last one. Okay, now we had a first example of an application of a second fundamental theorem of calculus and the average value of a function. Now I'm going to give you another few, okay? Now, the definite integral of the rate of change of a quantity f prime of x gives a net change or total change in the quantity on the interval a to b. What does that mean? So obviously we're using some sort of integral here, okay? So you have to keep that in mind, and I'm going to tell you the difference between net change versus displacement soon, okay? All right, so let's try one. I'm going to give you a few application problems so you know what to do. Let's go to this one first, okay? A chemical flows into a storage tank at a rate of 180 plus 3t liters per minute at a time. In minutes though, okay? Whereas 0 to 60 time is, that's 0 to 60 minutes, right? Find the amount of chemical that flows into the tank during the first 20 minutes. So just 20 minutes, okay? All right, I guess a lot of you are thinking, oh, I know how to find that, right? It's just an integral, really. It is. So you can go area is equal to 0 to 20 minutes, right? And your function is given here. And 2 dt. That's it. Okay? And then when you do that, just knowing these kind of cool techniques, like you can take the integral when you're doing something like this. It's really nice to know. So you get 180t plus 3t squared over 2. You take it from 0 to 20 minutes, and you end up with 4,200 liters. Find the amount of chemical that flows into the tank during the first 20 minutes. That means in the first 20 minutes, 4,200 liters have been flown in, okay? Flowed in, okay? All right, now I'm going to show you some particle moving things, okay? Now we have, okay, let's show you this example here. Okay, when a particle moves back and forth, we're going to see this velocity graph here. Okay, when a particle moves back and forth, so it's going up, down, up, right? The graph of the velocity against time is to the right. So this is the velocity and this is time. Okay, now we're going to tell you the difference between the displacement and total distance. Okay, now you see there's three different areas here, from A to here, and then from this area to this, and then from here to B. Okay, so there's three different parts, so I've marked them as A sub 1, A sub 2, and A sub 3. Displacement. Now, displacement, you just integrate. So I'm going to tell you some techniques here. If you're looking for displacement, you simply integrate. So that means you take the integral from A to B, and you just take the integral as you see this velocity function. Okay, which means you get this, which means you get A1, and you see how this is below the x-axis, so you're going to get a negative value. And then here, everything above the x-axis is going to be positive. So that's what you're going to get. Okay, that's displacement. Now, what's the difference between displacement on A to B to total distance traveled in A to B? Well, in this case, you have to integrate separately. Okay. Got to integrate separately and add positive areas. What do I mean by that? Okay, what do I mean by that? Okay, sorry about the terrible handwriting here. So what do I mean by that? It's this. You take integral from A to B, and you take the absolute value, which means what? It means so this absolute value, right? That means everything, even A1 is positive, A3 is positive, but even the quantity of A2 is also positive in this case. So total distance means A sub 1 plus A sub 2 plus A sub 3. They're all going to be positive. It's total amount. That's total distance. Displacement means you're positive here, negative here, positive here. So that's total displacement, okay? It's kind of like this. You know how when you travel to school and you travel back home, that's total distance because you still traveled, let's say, 50 kilometers each way. So that's 100 kilometers. But displacement means when you go forward and you go backward, there is that change, right? So it's going to be 0. You counter each other out, okay? Okay. So let's actually show you an example of that. So I'm going to show you an example of a particle, okay? Let's go to the particle. All right. A particle is moving along a line so that its velocity is v of t equals t cubed minus 10t squared plus 29t minus 20 meters per second at a time. So it's traveling, right? It's traveling. It's traveling from 1 to 5. So that's what we're going to discuss. They want to know the displacement of the particle on the time interval, and also what is the total distance traveled by the particle on the time from interval 1 through 5. So we're only looking from here to here, okay? From here, 1 through 5. So again, we have some positivity here, right? Right? And we got some negativity here. Okay, so I guess now you know what to do, right? So again, displacement. Displacement is positive direction, negative direction matters, and you have the total distance, which does not matter. So let's actually do this. Displacement's the easy part, right? So you're going to take the integral from 1 to 5, and you literally integrate. Okay, and dt. Okay, and that's going to calculate the positive and the negative nature of this, okay? So if you have a1 here, a sub 2 here, it's going to subtract them, okay? Let's go to total distance. That's you going back and forth from school to your house, and the total distance that you actually traveled, right? Okay, and that's going to be what? 2 separate ones, right? From 1 to 4, it's positive, yeah? So we're going to actually integrate that separately. Okay? And we're going to add that or subtract the negative part, right? Because this part's negative. So we're going to go A to B, 4 to 5. Why subtract? Because this part is negative. Therefore, we're going to subtract to get the positive, right? So I'm going to actually, let me just put this in parentheses so we can keep it more organized, okay? And then you go t cubed minus 10t squared plus 29t minus 20 dt, okay? All right, so it's separate, but it's going to be the absolute value. So think about which quantity is more or less, right? Is it going to be displacement always more or total distance always more? Okay, answer that question for yourself. And I think that's all for now. And let's try some work. Okay, let's try the rest of the practice problems for 5.4, okay? Good luck, everyone. Miss you.